Hello, everybody. We are in the week 2 of linear programming. Last week, we have seen how to solve inequalities using graphs. So this week, and we saw a few word problems. We got to introduce ourselves to those word problems. So this week, we are going to see how to solve problems using inequalities and how to determine the optimal solution for inequality problems. Yeah, how to determine the optimal solution. So last week we introduced ourselves to what is linear programming. Yeah. So this week we are going to see how we are going to apply that, how we are going to optimize linear inequalities to find an optimal solution for a problem with given constraints. Okay. So we took some real world examples to understand how to write inequalities. Like for instance, how to write whether it's greater than or less than a particular number. And today we're going to see how we are going to use that understanding to find an optimal solution like the minimum cost or maximum profit. So that's what we're going to see today, yeah? So before that, let's recap quickly. I want you to pause the video and answer these questions. Very good, that's right. X is greater than 2, exactly. X is less than 2. Here, X is greater than or less than or equal to 2, sorry. And in the last one, it is X is less than or equal to 2. Yeah. How about this? I want you to sketch the graph and then represent the critical region and send that to me by email. Perfect. Now let's take an example to understand linear optimization. This is how your exam style problem is going to be. Yeah. A firm wishes to spend at most 800 pounds per week on raw materials and has at most 200 hours of machine time available each week. It takes half an hour of machine time to produce a silk tie and 1 hour to produce a woolen hat. The raw materials for a tie cost £5 and for a hat cost £2. The firm only produces these two items. How many ties and hats should the firm produce weekly to maximize profits when they obtain £2 profit for a tie and £3 for a hat? So that's the given information. Based on the given information, you have to write two inequalities to represent the given information and then solve the problem graphically to find the maximum profit and then answer the question for a given condition or for a given change. Okay, that is, in this case, the profit for hat has increased. So what happens when you make such changes? So such questions should be answered. Yeah, so let's start with the problem. To solve such linear programming problems, you need to understand that linear programming is nothing but, these type of problems are nothing but optimization problems. Yeah, here you find the optimal solution. It could be maximum or minimum. In our case, it's a maximum profit. Yeah, that is a maximum optimal solution you're going to find. Yeah. So here, the decision variables, the values of the decision variables must satisfy the linear inequalities that we set up. So the linear inequalities which you set up using the decision variables, that is X and Y, are the constraints. Yeah, because that's going to decide how your profit is going to be. Yeah. And then you have to maximize or minimize a linear function of the decision variable, which is your objective function. Your objective function is to maximize or minimize, is to find the maximum profit in this example. Yeah. Okay, how are we going to do that? The steps to follow to solve inequalities, that's what I'm going to show you, okay? The first step would be to set up the inequalities, that is, set up the constraints from the given information. What is given from there, set up the inequalities. Second step, plot the inequalities graphically, and you have already done that, yeah? Shade the unwanted region, shade the false region, shade the region which are not solutions of the inequalities. Identify the feasible region, identify the critical region, identify the region where all the possible solutions satisfy the linear inequalities or the constraints. And finally, find the optimal solution by examining the points on the boundary. That is an optimal solution. What is it? It is an optimal solution is a feasible solution with the largest objective function value for a maximization problem, and it's the smallest objective function value for a minimization problem. In our problem, in our question, we are looking for the maximizing the profit. Yeah, we are looking for maximizing the profit. So we are looking at a maximization problem. That is, we have to look at the largest objective function value for this question. Yeah. So let's go back to the question. I've just bolded all the important numbers or terms which we have to use to make the inequality from the given information. The first question was to make the inequality, isn't it? Look at that, 800 pounds per week on raw materials, and we have 200 hours of time. What are we talking here? We have the cost. Raw materials for a tie cost 5 pounds, for a hat cost £2. And we have another category. We are talking about cost. We are talking about the time. That is another category, time here. Yeah, 200 hours of machine time, half an hour of machine time to produce silk tie, one silk tie, 1 hour to produce a woolen hat. So we have two different categories here. And then we have the type of clothing, the tie and the hat. So many categories, isn't it? So how many ties and hats should firm produce weekly to maximize profits? So our optimization tool for linear programming has to be used to find the maximum profit. Okay, so let's do the first step to set up the linear inequality. Okay, so let's imagine we have X ties and Y hats. Now let's set up the inequalities from the given information. The best way to do such problems when you have more than two categories, like we have here time, you have your cost, you have your ties, you have your hats. The best way is to draw a two by two table, yeah, which will make it simple to understand and put the whole information into inequality form. Yeah. Okay, so we have the time. So we know that it takes half an hour of the machine time to produce a silk tie. So I write the half an hour, and it takes 1 hour to produce a woolen hat. And the total hours is 200 hours. So we got that information. Now we're going to convert that into an inequality. Yeah. So we can say half times X plus 1 times Y will be the total time. Yeah, but here it says has at most 200 hours machine time available. So that means half time X plus Y is less than or at the most equal to 200. Yeah. So look at the last week we have used most of the words to understand how to use this in inequality, isn't it? Now, the next step in setting up the inequality is the next inequality. We have to find the cost. Yeah, what is given to you? 5 pounds, and for the hat it is 2 pounds. So try to fill that in this box. Now you have 5x plus 2y, but what is given to you? It takes half an hour of machine to produce for the cost now. A firm wishes to spend at most, what does it mean? At most of pound 800. So you can use that to make your inequality equations. Yeah, inequality equation in this case. So it will be 5x plus 2y is less than or equal to 800, isn't it? Yeah. So at most 800 pounds. Yeah. So now you have two inequalities as has been asked in your question. You have two inequalities to represent this information. Okay. Now let's go to step 2. What's our step 2? Plot the constraints graphically. Plot the inequalities graphically. So what are we going to do? We are going to draw the straight lines for the equation as we did in the last week. So you're going to write this inequality in the equality form, draw straight lines for the equality. How will you draw the straight lines? We put x is equal to 0, find a value of y. We put x is equal to 4 and y is equal to 0, find the x value in this equation, and then draw the straight line. Similarly, for this equation, 5x plus 2y is equal to 800. You find the x and y value, that is, you find the x-intercept and the y-intercept and draw the straight line. Yeah, that's the easiest way to draw a straight line, isn't it? Find the x-intercept and the y-intercept. That is the point where the straight line crosses the y-axis, that is your y-intercept, and the point where the straight line crosses the x-axis is your x-intercept. Yeah. So these 2 points, if you find, you can draw a straight line. Yeah, just 2 points is enough to draw a straight line. But the problem comes when the straight line is too close to the origin. Then it is better to have a third point. Okay, now we have to, the second step is to plot the inequalities graphically. So for the first equation, you have the y-intercept is 400 and the x-intercept is around 160, I think, yeah? And join the line. Yeah. For the second equation, you do the same way as we did in the last week. Find the x-intercept and the y-intercept and join the straight lines. Good. Now, what is our step 3? Shade the unwanted regions. You have done this too in the last week, so you know how to do it. Yes. You have to find the point 0, 0, which is easy, which is more convenient to you. Yeah. Substitute that point 0, 0 in both the equation inequalities and see whether the statement, mathematical statement, is true or false. And when you do that, you find that this is your false region, isn't it? So you shade the false region because you have to shade the unwanted region. And similarly for the other one, 5x plus 2y is equal to 0. Again, you know that 0 is less than 800. It's true. Yeah, just like this is true. So the other side is false. So this is true and that side is false. So you're going to shade the false region, the unwanted region. Yeah. So now you have shaded the unwanted region for both the inequalities, and that is your critical region. Yes, that is your critical region, which I have closed it with a blue line. Yeah, that's your critical region because profit cannot be negative. I'm not taking the negative values here. Okay, so that is your critical region. How many ties and hats should the firm produce weekly to maximize profits when they obtain pound 2 profit for a tie and pound 3 for a hat? That's our next question. Okay, remember guys, X is the number of ties, Y is the number of hats. Now, how do we solve this? Let's say P is the profit, okay? So for that, we have to identify the feasible region, which you have. Feasible region is nothing but the critical region. That is a set of all the points which satisfy the linear inequalities. And you have seen that already. So now let's find the profit. Let's say P is the profit. And then that would mean that P is equal to 2 times the number of ties, that is X, and plus 3 times the number of hats. So that will be a new equation for profit. Yes, so that is your objective function. Okay, that's what you're looking for, maximizing the profit. So look at all the points on the feasible regions. All these points in the feasible region will satisfy both the equations. But you want the maximum profit. And it is very difficult task to substitute each and every integer point or every data points in the critical region in this equation and find the profit. It is difficult. So the best way to do that is to find this greatest value for this objective function that satisfies a set of inequalities. The best way is to take the boundary points, the corner points, the boundary points which are in the corner. Take these 4 points and substitute that in this equation and find the value for which P is maximum. And then you can come to a decision to which value the profit is maximum. Okay, how are we going to do that? What are the corner points? Look for the corner points. 0, 0, and then you have 150, 0, and then you have 100 and 150, and then the last one is 0, 200. Okay, these are your 4 corner points. So the best way to do is, again, put it in a table, beautiful table, and put this corner points here and substitute the corner points into the objective function, into the linear equation. And when you substitute the X and Y value, you can find the respective profit. The corresponding value for profit. And now, once you've calculated the corresponding values for the profit for each corner point, compare them and see which has the maximum profit, which coordinate will give you the maximum profit, or which corner point will give you the maximum profit. And that's 650, isn't it? So that means this is your optimal solution for this given problem. And that is how you find the optimal solution. Okay. So another approach to do this is to find the point of intersection and then substitute this point of intersection, that is the 2 lines intersect at 100 and 150, substitute in the given equation, that is the objective function, to find the maximum profit, and then you will find the maximum profit. That is another approach here. So now we have seen how to set up inequalities, how to plot the inequality graphically, and then shade the unwanted region, identify the critical or feasible region, and then find the optimal solution, which was the maximum value in our case. So these are the 5 steps you have to follow to solve an inequality problem. Okay. Now let me tell you another approach where you can choose a arbitrary value. You choose a profit value and then find the max and then decide. Come to a decision. Okay. For example, you can fix the profit to be 480 pounds. Then your equation P is equal to 2x plus 3y will become 2x plus 3y is equal to 480. And you can write this in the general form and see that the slope for this equation is -2/3x. Yeah, I'm just rearranging this equation. Yeah, that is, I'm just dividing the whole equation. First, let me do that for you. 3y is equal to 480 minus 2x. And then I'm going to divide the whole equation by 3. So it becomes minus 2x plus 160. And that's what I've written here. Okay, I have just rearranged and put it in the general form. Okay, so look at that. This is a straight line with a gradient m is equal to -2/3. So all the points on this line must give a profit of 418 pounds. Yeah, so all the points on that line should, because it's a negative gradient, I'm drawing this line down. Okay, should all these points on this line should satisfy this equation and give us a profit of 480 pounds. Okay, guys. So it should look something like this. Because it is -2/3, I'm going to draw and look at that equation. The point, this line should cross the C at 160. Yeah. And because this gradient is 2/3, I'm going to write this as 160 over 240. Look at that. That's how I got my other point. So this is nothing but 2/3. See, that's my slope. That's my slope. And because it's going down, for every 1 unit I go along the x-axis, I go down by 2/3 because the gradient is negative. Yeah. Every 1 unit I go along the x-axis, I go down by 2/3 because it's a negative gradient. I go down along the y-axis. Every 1 unit I go along the x-axis, I go down by 2/3 along the y-axis. Yeah, so I can easily find the point at 160, and then I can find the point where it crosses the, yeah. The best way is to put x is equal to 0 in that equation and find y. Y will be 160, and then put y is equal to 0 and find x, which is nothing but 240. Yeah, that's how you find the line. Yeah, and what is this line called? It's called isoprofit line. Now, if you change the profit, that means you're changing, this is of the form, remember guys, this is of the form, we saw that in week 5, if you change the value of C, what happens to the line? If you change the value of C, if you increase or decrease, it will just be a straight line parallel to this green line, the isoprofit line. It will be just a line parallel to the isoprofit line. Yeah, so if we change the profit, we are only going to make this isoprofit line go up or down, but parallel to this line, something like that. Yeah, at one point it will cross this maximum value. Okay, so it's because we're changing C, so it's going to be a parallel line. We're not changing the gradient. So this line is called isoprofit line, and you can use this to find the maximum value. This is the isoprofit line approach. That's another method to find, yeah? Okay, now the last question was, in December, the popularity of the hats increases during the extreme cold weather, and this can increase the price so that they can make £8 profit on a hat. Does this change the feasible region? What is the answer to this question? The equation will look like 2x plus 8y. P is equal to 2x plus 8y. This is just, what are we doing here? We are just changing the objective function. we are not touching the constraint. And the feasible region is decided by the constraint, by the linear inequality equations, the constraints. Yeah. So the answer will be no. There will not be any change in the feasible region because the feasible region is defined by the inequalities, the constraints, and not the objective function. And hence, there are no changes to the corner points. Okay, the corner points remains the same because the corner points are decided by the inequalities, by the constraints. And we are not changing the constraint. What we are changing is the objective function, p is equal to 2x plus 8y. Is that okay, guys? Okay. So we have seen that we can solve word problems in real life to find the optimal solution for a problem in linear programming. That's all for today. See you in seminar. Thank you.